here. It's good to see everyone today. So we can just do some introductions real quick and just see what everybody's working on. My name, of course, is Keegan, founder of Canlytics. And so this past week, a lot came together. So the software, the API is now up and running smooth, testing it in multiple programming languages. At the moment, Python and Node, and working well. And it's funny how things work, but a piece of Canlytics code, the generation of certificates, has now been used to generate certificates in production. So
congratulations.
Thanks. It wasn't the anticipated piece that was going to get used first, but that's how things work. And so a small piece of the code has been used to generate certificates. And so now I'm just going to expand on that and keep improving that functionality.
Which state or?
In Oklahoma.
Oklahoma.
So
great.
There are some licensees out there with certificates that were partially made with Canlytics software.
That's cool.
So baby steps. So So how about everyone else? Any other exciting forays into data in the past week or so?
Not data, but quality control issues.
What quality control has come up?
So concentrates shouldn't taste like eggs. However, if sulfur is not cleaned up in the process, it can become very concentrated. So when it combusts, it becomes sulfur dioxide, and it's very obvious. So that's a quality control error that I experienced recently. But the only challenge is that the people at the dispensaries have no idea what I'm talking about because the extraction site is many, many miles away. So anyway, everything was fine. It's just I find these quality control issues to be exciting and demand attention. Yeah.
Well, that's an interesting, relevant issue. So we're looking at some of the data from Washington State, looking at the lab results, and I thought I would just do what I preach. And so last week I was saying, oh, we should look at the failure rates for the different solvents and microbes, microtoxins. So I actually went ahead and prepared those statistics today so we can at least look at them. A lot of the data looks like a lot of the potentials in cannabinoids, but I'll show you the failure rates as is. So I know Charles has done some interesting work here. Paul, real quick, have you done anything?
Yeah. So unfortunately, most of my time's been spent writing my paper, but I should be ready to share some results next week. So I've gone through the entire process of selecting candidate dispensaries for analysis. And so I've gone through that process, and I showed you a little bit of that previously. And I have ran through my market basket analysis for those 3 dispensaries, looking at the various combinations that emerge as far as product associations and natural product grouping. So I'll have something to show next week if I could do that and let you guys see what I've got up to.
Definitely. Always interested to hear about your analysis, and then even if just this week anything interesting had popped up in your literature review, feel free to share it with us.
Okay.
So, and then Charles, I almost wanted to save it in case things go wrong, but I've done a bit of prep, so last week ran out of memory as I was presenting last week some of the data, and things ended abruptly. So the recording goes on. So if that does happen today, then just power on, and maybe Charles, you can pick things up. However, but I'm interested to hear what your analysis before I go on a spiel. So you wouldn't want to talk about some of this analysis that you've done recently? And hello, by the way, Melody.
Hi.
Hello. I'm sorry to interrupt. I have an 8-year-old with really severe epilepsy, and I'm a beginning data scientist. And so she's a little noisy, so I'm going to put myself on mute.
Well, it's awesome to have you here, Melody. We're all learning, and so you're in the right place. So we'll just be talking about analytics, coincidentally about cannabis. So we typically have a fun time. So.
Perfect. Thanks. Thanks for having me.
Oh, by all means, welcome aboard. So just to introduce, so Charles has been looking at some of the cannabinoid statistics from this data set we have in Washington State that has essentially all of the lab results from the traceability system up through the end of 2020. We'll get the newer data set. But for the time being, we'll just look at this historic data. And so, Charles, you would want to introduce what you've done real quick?
So I've been going through the lab results data frame column by column, and looking at the number of missing values, just sort of plotting it all out, getting trends, showing percentages of failures based on or how they correlate to other columns, and just kind of just basically going through it and looking at everything, because trying to use a classifier to figure out which samples were going to fail and not. There was there were certainly some issues, and it came no matter what I tried, it always seemed to turn out to be just a glorified dummy classifier. So so now I'm going through and looking and trying to figure out like what data really matters and what data is just kind of maybe kind of what data is too messy to use, and just kind of going through the whole thing and just looking at it overall, and so that we can look at each column and see what if any information is really there.
So I was doing a bit of exploratory analysis here, and maybe I'll start sharing some of my work here. So essentially what I was thinking was, okay, so there's low failure rates. So it may be just tough to predict failures, but perhaps if a failure occurs, maybe that's a sign of maybe a larger problem at hand. So I thought maybe what would be worthwhile is, okay, let's just look at the samples that fail and what's going on with them. So I haven't gone too much further down that rabbit hole, but I'll show you essentially how you can find those samples. And then perhaps, Charles, you could maybe help me with this. If we attach all the data points, right? Because we'd want to see, okay, what's the strain, potentially what's the geographic location, and it would just be interesting to see if we can't pin down some essentially other issues going on there. So, do cultivators that fail, do they have, lower than average cannabinoids, or do they have above average moisture content, below average moisture content? So that was sort of my idea was, okay, let's isolate the failures and see if there's anything else going on with those samples. So do they have, statistically different X, moisture or what have you. So long story short, I'll go ahead and just start presenting some of this data. And in doing so, we'll essentially pick back up where we got interrupted last week, where we were replicating a cannabinoid analysis from edibles in Jamaica. So let's present. All right. So we're essentially working with these lab results, and just to give you a look at what a lab result or just an observation looks like. We essentially have many data points. Most of them aren't that useful, so the pesticides aren't reliably entered in. So the key variables that we do have are, we've got the cannabinoids, principally THC, THCA, and CBD. And we're able to use some other identifiers. So here we can actually identify the lab. So this came from lab 12. And you can identify which licensee this was tested for. This was tested for license 413, 287. And then you can even connect this to the inventory item. So that way you can get the strain information and perhaps more information such as harvest date. So we'll need to connect that data. So since we were already talking about solvents and microbes, I'll go ahead and show you the analysis I've done there, and then we can move into the cannabinoid analysis, where we can finish out replicating the analysis we were intending to replicate last week. So we've read in our data, and then it's worthwhile to note that, okay, not all of the samples are the same. So the main distinction you have here is essentially the intermediate types. I did a bit more research, and so essentially the flower is when it's harvested, then it's packaged into flower lots, which are then sold as usable marijuana. So what's sold at the stores is usable marijuana. However, they're having typically their flower lots tested. However, sometimes you have the flower tested immediately after the harvest, I think, before it's sublotted. So I think those are what those lab results are for. So what would be worthwhile is still, I think, to connect the lab results to what's actually sold at the store, and maybe only look at those lab results. Because at the moment we may be including things in analysis that aren't even ever sold at a store. So right now we're just looking at essentially the entire population of cannabis that was tested, whether it was sold or not. So just to look at the concentrates real quick, essentially just grouped everything that appeared to be any sort of concentrated product. So the main ones are hydrocarbon concentrates. Then you also have concentrates for inhalation. Then I even included the non-solvent-based concentrates almost as a sanity check, as well as food-grade solvents. And then, of course, CO2 concentrates and ethanol concentrates. The main all of the solvents are listed here. So everything from acetone down to your xylenes. And then I collected the limits. So last week I mentioned that you can find the Washington State mandated limits in their administrative code. And so essentially I got the limits that they have listed here, and I put them in this spreadsheet using the keys provided. So that way we can match up, okay, acetone has a limit of 5,000 parts per million, so on and so forth. So collected the limits. And so now we've got all of the data we need. And so for starters, I said, okay, let's just look at the average concentration of solvents in each concentrate. We'll need to define the concentrate types. And so we can now start to just look at essentially the baseline concentration in all the concentrates, just to get an idea of what may or may not be present. And so keep in mind that certain samples may have high parts per million, whereas many other samples would have none. So you start to see that, okay, things like concentrates for inhalation, they never test for solvents. Hydrocarbon concentrates, they're coming out of, across the board, low concentrations, but you're getting hits for the various solvents. What's interesting here, you are getting a few hits with the non-solvent based concentrates. I included infused mix. It doesn't look like those may not get tested for residual solvents. And so we're just essentially just trying to just start building some conditional averages here just to see, okay, what solvents may or may not be present. So now, as I mentioned in prior meetups, that, okay, let's look at the failure rate for each solvent. So, okay, so here, essentially, just essentially given a sample, so let's just, given, say, a sample, so this one wouldn't have acetone, but given a sample's acetone level, we can compare that to the limit for acetone. And if it's above 5,000, it's a failure. If it's below, then it passes. So we'll just manually compare these to the limits and essentially try to calculate the failure rate. 1 second, I'm going to suppress these warnings just so it comes out slightly neater for us. So what I can show you here is there's quite, as Charles was noting in his general analysis, the failure rate is low. So your failure across the board. So your highest for hydrocarbon concentrates, your highest risk is butanes, and you have a less than 1% chance of failing for butane on average. And so here are just the conditional averages for each solvent, for each method of extraction. And as you'll see, I don't see any with above a 1% chance of failure. But so long story short is it may be, as Charles was noting, it may be tricky trying to predict failures. So it may be just more worthwhile looking at specific failures and trying to figure out, okay, what went wrong in this, in this situation. Just to continue in this vein, was also going to look at mycotoxins, which we also have limits for. And I was just going to look at some of the microbials. So in particular, these correspond to the enterobacteria. So this is what I would just generally describe as an uncleanly cultivation site. So I think that's what would lead to you failing for microbes. And so I think it's worth looking at one way or the other. So that way we at least know what they are. So if we look at mycotoxins, we'll actually see that there's really almost no failures for mycotoxins. So you're seeing, very low percentages. You're seeing, a handful, well, not even a hand. Yeah, so just basically a handful of flowers that are failing, as well as, you've got some non-solvent base that may fail for ochratoxin, marijuana mix. So essentially what I was thinking was, okay, why don't you just identify, these flower lots and potentially see, what's happening there. So for example, well, I'll write this snippet here in a bit, potentially. Well, let's just do it right now. So essentially what we're looking for here right? So here is all of the flower data. And so you can essentially find all the microtoxin failures of flower. You basically say, okay, let's find all the flower data where the aflatoxin was greater than or equals to 20. So you'll see, okay, so there's only 45 failures for mycotoxins. And so essentially what I was getting starting to come around to is, okay, it may not be worthwhile trying to predict a mycotoxin failure, but why don't we look at these samples here and see if there's something that, they have, see if they're statistically different in some way. So this is where I was saying, like, okay, like, do they have, above or below average moisture, right? So here they have an average moisture of 7%. And so we can just say, okay, what's the average moisture content on a whole? So you're seeing, okay, the moisture content as a whole has an average maybe around 5%. So the standard deviation here is high, so it probably wouldn't be statistically significant. However, you could do a test and say, okay, is this mean statistically different than the average? In this case, it actually does just eyeballing it, looking at the high standard deviation, it doesn't look like it's going to be statistically significant. However, you could go through the various variables and see, is there any pattern?
Keegan, I have a general question. A couple of weeks ago, you provided some analysis and some thinking behind. There's a work that you're working with another gentleman, and it was for outdoor cultivation. And I think there was higher failure rates for the outdoor cultivation tests as opposed to what we're looking here for Washington State, which I believe we're looking at like the indoor grows here. Have you noticed between, and that, there's two different ways of growing, but have you noticed between different states, just kind of more systemic failure rates, like looks like here in Washington State is pretty low. Do they all tend to be pretty low for the various states you've seen, or?
Anecdotally, I've heard various things. So I think it varies state by state. So it matters, and the regulations matter. So it's not a state, but for example, I think I've heard that failure rates may be high in Canada. And so a lot of it depends on, okay, what are you testing or screening for? And what is the threshold, the limit for failure? So the lower your limit and the more pathogens or analytes that you're screening for, the higher your failure rates are going to be.
Yeah, it seems like there's a lot of, from a public health perspective, it seems like there's a lot of wiggle room for variation across all the different states, right? It seems like that there's, I don't know, not a single standard. Obviously, the states run it their own way, but I don't know. It seems like there's a lot of areas where it's going to be hard to really know from a consumer perspective, just, how safe is my product going from state to state.
Well, I was going to give them a shout out real quick, but we'll have to revisit that. So I think that's fruitful analysis. I'm not 100% certain how you would frame your research question, but essentially what I think you'd be trying to uncover is, okay, are like the regulations, I guess, guiding, I guess like the argument put forth has been, okay, so say in California, they have strict regulations on microbe levels and pesticide levels. The idea is that cultivators in those states get skilled at keeping their microbes low and their pesticides low.
Mhm.
I,
So I know at the time, the recreational marijuana was legalized in Oregon. Oregon was supposed to have the strictest standards, and it was certainly, they were a much higher standard than what was in Washington and Colorado at the time. So I don't know. I mean, a lot of other states have legalized it since then. So I don't know if those states have enacted stricter standards or if they're more lax or if they're the same. But I guess that's probably easily obtainable information, and that might be a good comparison.
Yeah, I don't want to derail the conversation too much. Good. It just, the analysis that you're showing, Keegan, just got me thinking, and just the standardization, I guess, is the word I'm thinking of here. But,
well,
go ahead.
You brought it up at the prime time because here we are essentially talking about microbes, and this is what the microbiologists are stressing. So you've got people in a lot of different camps here. And so there are people in the camp that think that we're not really screening cannabis enough or for the right pathogens. And so there are people in the camp that think, okay, we need to be, screening more essentially. And then there are essentially some people in the camp, I met them. So they're basically saying like, okay, it doesn't necessarily make sense to be screening everything for I don't want to put words in people's mouths, but for all of these pathogens. And so I'm not certain which ones per se. So like I said, you do see failures for certain ones of them, but it seems that, okay, maybe we don't necessarily need to be testing for mycotoxins. And like I said, I don't want to put words in people's mouths, but I'm not certain which ones, but the mycotoxins or potentially some of the microbes like salmonella. I don't think you really see samples failing for those, whereas perhaps there are other contaminants that may be worthwhile screening for, like perhaps, so in Washington State, they don't really have the yeast and molds, to my understanding. So I think just from what I've picked up, it seems that, okay, maybe we're screening for the wrong contaminants and not across the board, but some of them, maybe we may be doing excessive tests for microbes that aren't really expected to be there. And we may not be testing for microbes that are worthwhile to be screening for.
Yeah, it seems like time will tell what the consensus is on a lot of these things and whether the federal government gets involved on overall standards and that sort of thing.
Exactly. And so perhaps even for next week, since I always try to pick out sort of an interesting topic in the week that I don't actually know enough about and try to research it for the next week. So I could start looking into some of people's perspectives on, especially in the lab space, on microbes. So what should maybe be tested more? What should maybe be tested less? What do we have right? What states have it right? What states have it wrong? And so then we can almost do a state-by-state comparison of the various regulations and see, and even how those regulations may have changed over time. Because in Washington State, they changed which microbes were being screened for, and this may have happened in other states. So I think,
yeah, I could see if you went down that path. And I don't know if other analytical outfits are doing this type of work, but if you were able to pull that information together to a certain level, it'd almost be like Canalytics could be in an advisory position based on that knowledge that you've compiled, right? Because I just see, not that I'm not very knowledgeable in this area, but I could see that, the force is pushing in that direction. And if you position yourself with that information, you might be a good resource for others.
That's definitely something that we want to incorporate in the Canalytics platform. So essentially, we see the lab testing community as really just one big community of labs, right? So you've got labs all across the country, and a lot of them are doing the very similar things, right? So here you've got labs in Oklahoma, and they're testing cannabinoids, they're testing pesticides, just like people in Washington State, and just like people in Colorado, just like people in Michigan. And exactly, and so we essentially have a platform here that can handle, okay, yes, the limits may vary state by state, but you're still doing the same process. So
yeah, so in general terms, in any kind of market, the folks that develop a platform, you can think of Uber and search engines and anything else you can come up with, but those who have the platform that connects all the different groups together based on what it is they're trying to accomplish usually ends up being in a pretty good position.
yes.
So
Well,
just think.
And just to, I guess,
you.
to toot our horn real quick, since it is up and running, can essentially show you essentially what that would look like, just at its simplest version. So essentially, you'd have your set of analytes. And so, for example, let's see if we can't find a nice microbe. So Aspergillus. So, for example, this limit, I've got it set at 1 part per million. So I think, so I think they've got, a 1 part per million restriction on Aspergillus in Oklahoma. I just use that as the model for these limits. Well, let's see if there's any other.
So you would be able to look across all the various different companies that are using your platform, and then across one particular analyte here, you would be able to see all the different limits that they're using.
Exactly. And so we would even want to try to help out a little, but essentially, the limits are going to vary state by state. Everybody's essentially doing the same thing. And yes, it would be then interesting to then measure, like, okay, do those limits then have an effect? So are people failing samples more or less in some states or others, depending on the limit? And I think the reason that would be significant is there's a truncation effect that they talk about in economics. So whenever you're running, right up to the threshold, well, that can affect your analysis for starters. And so the reason I feel like that's relevant here is, okay, let's pull up the Midwestern hemp database here real quick, because I think this is a good example of exactly what I'm talking about here. So here, essentially, this red line is, you can think about that as your failure rate for cannabinoids in hemp. And so you would expect that this would be similar for, so let's just pretend that this is for various other compounds. So say this is, for salmonella or something. So in this case, and I think at the federal level, they are looking at adjusting the threshold to THC. So in hemp. So this would be a limit where I think it would lead to misleading outcomes, because you're basically saying that, okay, something on this side of the red line is passing hemp, and then something on the exact other side of the line is failing hemp. And so you can get misleading results essentially. And my concern is, what if this was happening with, like, you wouldn't want to see this happening with a microbe. So if you had something like this with your microbe, where there's some, a lot on one side and not many on the other. So my point is, you're basically going to have things that they look like they passed, but they're really just shy of failing.
Right. Yeah. There you go.
So
Right.
hard concept I'm trying to convey, but basically, how do states want to set their thresholds? And so, like, obviously in Washington State, it looks like the bar for microbes is really high. And so let's just kind of throw these axes out the window. But basically, the red bar is not capturing any of anything, even if it may have high microbes. Whereas in other states, they may, lower the threshold. But then you may wind up in this scenario where you're essentially failing samples that look quite similar to samples that pass.
Yeah.
So,
yeah, it's not subjectivity, but there's a certain level of reasonableness that you have to apply to these thresholds.
exactly. And so I guess I guess maybe this is because coming from the economics point of view, I think, okay, well, it just comes down to a cost benefit analysis. What's the, obviously there's a cost of increased testing, and, there's a benefit as well. So, essentially the public safety. And so from the economics point of view, I think it would just come down to a cost benefit analysis, where you just try to measure the benefit to the public and try to balance that with the cost of essentially more testing, and then the cost to cultivators for having to, jump through all the hoops necessary to keep your failures low. So,
Right.
but that's where I'm coming from. Different people come from different places, right? So you've got the regulators looking at this situation, and they weigh the public safety highly, and then the businesses are coming from it from their point of view, and they're going to be focused about the costs. So
Good stuff.
So anyways, we went down that rabbit hole. So just to get back to the data real quick, and then in the last bit of time here, I'll just kind of wrap up that cannabinoid analysis, because I thought that was kind of interesting. But here's just the look at the microbes real quick by sample type. What I noticed was interesting here, so we'll come back to this in a second. So if you look across the board, you'll see, okay, you know, you're having some flower lots fail for microbes. And then you're actually having, you know, above, you know, slightly higher marijuana mix failing for microbes. And from my experience, this is essentially what you'd expect. So a lot of the times, the marijuana mix just ends up being some of the, anecdotally I've heard, ends up just being some of the loose bits that may be kind of left over after trimming or after packaging. So they may get everything packaged and they just may package up all the loose bits as marijuana mix. And so when you would expect, when you do that, there's just going to be more microbes in that mix. So they tend to fail slightly higher than average for microbes. And then the other thing I was going to point out that I thought was interesting, and this you may need to drill down a bit because summary statistics can be misleading. But I saw, oh, like there's a non-negligible portion of non-mandatory samples failing for micro. And so what that looks like to me is like maybe people may suspect that they may have a dirty environment and they're trying to do just some almost like research and development to try to get things cleaned up proactively, but don't want to attach too much of a narrative to that because I think further drilling is needed.
So the non-mandatory plant sample makes up 0.012% of the samples.
Exactly. So it may almost be an insignificant amount of the sample. So
yeah. So I mean, one failure could make it look really statistically significant when, there might only be one or two, or I don't know, maybe like 10 samples or something. It's not a whole lot.
exactly. And so it's an outlier. And so I think, yeah, instead of chasing that, I think that what's worthwhile here is, okay, maybe you may want to look at the flowers and the marijuana mixes and see if there's any pattern that you could uncover. Because basically, what are you trying to do here? You're trying to find some factor that may help the cultivators have a cleaner environment. So if you just look at all the failures and you notice they're all in this, like this is like the classic example of statistics, and I unfortunately don't remember the name of the statistician, but basically they were looking at, I think, cholera outbreaks, and they were looking at wells, and they said, oh, they realized, oh, many people that frequent this well, they're suffering. And so you could essentially try to do that with cannabis. So you could say, okay, let's look at all the failures for microbes and try to uncover a pattern. So are all the microbial failures, are they right beside cow pastures or what? So there may just be nothing going on there, but I think it's worthwhile trying to find out, because let's say you discover something and you're like, okay, people beside cow pastures have a 15% greater chance of failing for microbes. Well, if cultivators knew that, then they may not want to set up shop right beside a cow pasture. And so it's just, the more the better operation you can run. That's my spiel there. And so now let's go ahead and finish out the cannabinoids from from the prior week. So for Heather and Paul, just to show you what we're doing here, basically just looked in the literature, tried to find an analysis that people were doing, saw that there was a recent paper here, July 10th, about people looking at edibles in Jamaica. And what jumped out to me was, okay, they actually only have, 45, a sample of 45, which is, better than nothing. And so, they were just looking at the THC, CBD concentrations. And just to show you a chart, they're just measuring these in the lab. And so then they get their THC CBD ratio in the edibles. And so essentially thought, okay, we can replicate their study in Washington State and just look at the THC CBD ratio in edibles here in Washington, just to, just a demonstration of what we can do and how powerful our analysis is. So we can go ahead and isolate the solid edibles and, just to toot our horns a little bit. So this is what's cool about Washington State's public data is over the prior years, and this is where we crashed last week, was we were basically saw, okay, from 2018 to 2021, we have almost 9,000 solid edible samples. And so, we can do some good analysis here. Quick note. Cannabinoids are coded as either percent or milligrams per gram. It looks like a handful, well, more than a handful, 460 samples were coded with THC percent, and the rest were coded with milligrams per gram. And so you can actually convert percent to milligrams per gram. So when you think about it, there's 1,000 milligrams in a gram. So, if something is 10% THC, well, then that's going to be 100 milligrams per 1,000 milligrams or per gram. So that would be 100 milligrams per gram, 10%. So you can convert percentages. So say you've got 10% here. You've got 10% there. You can convert 10% to milligrams per gram by just multiplying by 10. So now you just take your 10%, you multiply it by 10, you now have 100 milligrams per gram. So the only thing that hung me up was just coding it up real quick, but we can basically convert everything that's missing milligrams per gram, but does have the percentage, and we can just put everything in milligrams per gram. Just for the sake of time, I have not actually solved this yet. So if anyone wants to try to solve this line of code, then by all means. Otherwise, I'll look at it for next week. So long story short, we can look at the THC and CBD in edibles here. And so hopefully, I'm probably going to need this chart up here. And then hopefully this just works. So just real quick, essentially we were just seeing, okay, can we essentially replicate their study, but do it in Washington? And essentially we have. So keep in mind here, I'm dropping outliers. So I'm dropping the top 5% because you see things that have potentially unrealistic levels of THC and CBD. So I was just dropping the outliers. So excluding the outliers so we can actually get a decent looking chart. Let's compare this to, well, actually, what I may be able to do is I may have printed this off. Okay, so it doesn't look like it printed correctly. So I'm just trying to get these charts side by side to a decent, so bear with me here. Okay, so we have similar charts. So we're both seeing that, okay, the THC to CBD ratio, it's typically less than 50. And so their mean was 29, was around 30 milligrams of THC to 1 milligram of CBD. We're seeing that it's around 20 to 1. There's standard deviation 54, ours is 34, or around 33. So
sorry, Keegan, I'm sorry to interrupt you. I do have to drop for some work-related activities, but I'll give you a call later today if you're available. I wanted to talk to you about a couple of things about the graduate project.
Definitely. And we'll be wrapping up here in a second, but thank you for attending, Paul.
Thank you, Keegan.
Yeah, definitely. And if anyone else has questions about some of the analytics we're doing here, just always happy to talk cannabis data. So,
all right. Thanks, guys. We'll talk to you soon. Bye-bye.
Have a productive day now.
Thank you.
Bye.
And then just for everyone else to go ahead and bring this home here. So essentially what we're just doing is we're just saying, okay, yes, not only can we look at, so basically we can start looking at analyses that other people have done, and we can potentially replicate them in Washington State with a greater amount of data. Of course, it's different. They're looking at Jamaica and we're looking at Washington State. However, we're both looking at cannabis edibles, so there could be things to uncover. So this wasn't just a simple analysis here where we're just, we're just looking at the THC to CBD ratio. But, now we know. And so how is this valuable? Well, so now if you're a processor, an edible manufacturer, well, now you can know that, okay, most people are producing edibles, that are less than, 50 to 1 THC to CBD. And, dialing in your ideal ratio is often part of the challenge for the edible manufacturers. So it's a tricky thing to do. And so yeah, so I think this could be worthwhile analysis. And like I said, this is just a start. So, now you have a whole nother variable here, your THC to CBD ratio. So now you can, once again, you can do analysis and, okay, do any of these other factors we're looking at, do those influence your ratio? No? So there is a lot more to be done here with analytics of cannabinoids. So I think I'll go ahead and conclude there because there's so much to do that, you know, you may have to start looking through some of this on your own. So, but real quick in the last few minutes, any questions, comments, ideas?
I just, I guess I don't mean to be dramatic. I just feel a little moved by the last graph that you showed with the red line and the lack of what I think is a suitable distribution around the failure point. You know, all your points being clustered. I mean, that's extremely unsettling. I'm going to say that I've been privy to that in the lab directly, but not when it really matters like this. Like,
Well,
I don't know.
keep in mind how that was hemp we were looking at. So that was hemp failing.
I understand.
Yeah. But it is something to, yeah, I'm sure the hemp producers would appreciate you being up in arms about that because it's just tough, right? Because like say you're a hemp producer and you tested it 0.31%, and then the guy down the road or the girl down the road tested it 0.29%, and you've got to destroy your harvest, and then they get to go on and make a small fortune. Yeah, that can hurt. And
Yeah,
so
just now you need to start setting up cameras. Like if I'm going to be growing my own stuff, test it just before you chop, or as you're chopping, better be on camera. Like when are you testing? You know, I just there's just so many things to consider. Maryland State, for example, flower tests super high in Maryland, and I don't know why. It's also very, very dry. So when, you know, the numbers that you're referring to, at times they seem low, but that's because of the numbers that we're looking at in Maryland that are very standard. So it's not to say good or bad. It's just what gives rise to that. The method of testing. There's so many things that go into the testing. You're referring to testing edibles, testing the center of it. Oh no, like just it's so complicated. I'm not saying it's overwhelming, but I'm intrigued more, and I just I'm gonna keep on listening.
Oh, no, you bring up interesting points, and then with the edibles, that's what people are always asking. So typically, what they have to do is send in the entire edible, and then they'll
Oh,
they'll dilute, or they'll you know, dissolve it, create a dilution, then test that. And so, you know, people are always it's always a question, oh, do I test the inputs? And then you raise an interesting point with hemp. When do you send in the sample? So maybe some people have techniques that they know when to sample, to make sure that they're staying below the permitted THC levels. And maybe some people are naive and they may not know. And so it's a tricky dance to dance. And my only consolation consolation to hemp producers is as far as I thought they had raised it for a second, but it looks like they may not have. But there's definitely noise about them raising the hemp requirement to, I think, 0.6 or 0.75. And so, I mean, you saw the chart. And so if they did raise the hemp permitted THC to 0.6 or 0.75, then that would allow a lot more hemp into the market. So.
do they know the conversion rate? Is the like 0.03% that you were talking about with THC for certain states? Is that based on the conversion rate that they know? Like, how do they know?
So that's after essentially you apply conversion rate to THCA, because THCA decarboxylates into THC. So technically your total THC, which is delta 9 THC plus 0.877 times your THCA, the combination of those is your total THC. So your total THC for hemp has to be less than 0.3%.
Meaning to say their concern is that if there's beyond a certain level that it will, the THC level will go up beyond a certain point. Do they know that potential?
I think
Yeah, sorry.
I don't, as you're picking up, there's a lot of things that may not make entire sense, right? Because, okay, say you got it tested, okay, yeah, your cannabinoids, yeah, they may change over time. So
Light. They're exposed to
that's
light, photons. I mean, these compounds must be sensitive to light, and I know that they are. So,
exactly. So perhaps your crop's CBGA heavy and it passes, and then over time that turns into THC. So there's not a lot of nuance taken into consideration in the rules. It's just the rules are just pretty flat. It's just 0.3% THC. This is how you calculate THC, and
thank you.
that's what it is.
Thank
So,
you.
and that's why why we're here to help. Is we're just trying to, one, just let people know, okay, these are the rules, and then two, provide them with analytics to see, okay, given the rules, how can we say we want to grow hemp? How can we grow hemp to make sure our probability of growing legal hemp is high? And just because that reduces your cost, we're just trying to help people create value.
Yeah. I'd like to know what sort of data I can get a hold of in my state that's free,
You said
or
you're in
anything.
Maryland?
Yeah. So we are medical only. So we have three certified labs to test cannabis. So whoever that is, I mean, well, we have quite the monopoly here because we're not fully recreational. So there are companies that like to apply for their certification and they get it and they get spots number 1 out of 6 or whatever it is. So unfortunately, the monopoly is just getting out of control. But our program is pretty decent. We just all samples they go to that certified one of those three testing centers. And yes, I've applied to those jobs.
So
Don't
I
worry.
put a link in last week's README. I'll send the link to you. So there is
Thank you.
some Maryland data, primarily with sales.
Oh, that would be interesting.
Yeah, so you can at least look at the sales data. I'll 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 try again to see if there's anything else I can scrounge up for Maryland. I think it would just be useful in comparison to like in a comparison study. So what I'm becoming curious about is maybe look at per capita. So, okay, does maybe Maryland have above, below, or typical consumption per capita? So maybe not even, but any data points we can get, look at it in comparison to other states and see if there's any juice we can squeeze from this rock.
Yeah, I'm interested. I like state to state stuff. People in Maryland are just itching to get their specific strain of flower from a different state, even if it means to travel. From a customer perspective, our priority is the strain that we like. That's our medication. I'm not speaking for everyone, but it's a general sentiment that people have here. So I love the state to state combat.
Okay, well, that came up earlier with regulations, so maybe we can try to combine this, and next week may just do a deep dive into regulations, state by state. So okay, testing regulations. What's going on? How's it affecting people? So that could be a good topic.
Yeah, or lack of testing. Like, I'm not saying that, no, our stuff is tested. It's just every now and then we get a little strange QC error, some sort
Oh,
of
yes,
issue.
and that's what we're talking about. And that's something I want to leave you today with is be careful what you measure, right? Because if you're only measuring acetone or butane, then that's all you're measuring. And so in Heather's case, then yeah, it looks like everything's fine. It looks like pass. Just put a big green pass on it. But you just may not have measured your
Sulfur.
sulfates.
Oh my God. Just no.
So be careful what you measure.
Thank
So
you.
that's the lesson of the day. And with that, I want to thank everybody for coming. Thank you, Melody. Thank you, Charles.
Thank
Thank
you.
you, Heather.
Thank you.
Ah,
Yeah.
Enjoy
Always
your
been-
day. Have a productive week now.
Yeah, I'm gonna
I
try.
appreciate it.
Take it easy.
Definitely. Well, until next week, keep your nose to the grindstone.
Right on.
All right. Bye now.
Yeah. Bye.